In the diagram, A, B, C, D are the vertices of the quadrilateral, having AD and BC being parallel to each other. And BA is produced and has an x-intercept at E. This is an x-intercept of line AB. And we can see that BD and AC intersect at M. BD and AC, they intersect at this point M. Then what are we having? We have N, which has a coordinate of T is to 0, is the point on the line AD. So this N is the point, and you are having T there, which is the unknown X coordinate of N. So what is required here? You have to find or determine the gradient of BC, the gradient of this line. The gradient of this line, we know that it is positive. Gradient of this line is greater than 0 because the line is going up as you go to the right hand side of the cartesian plane. So it is wise to know that information, that for the line which is increasing, it must have the gradient which is a positive. Now, how do you determine the gradient between 2 points, having this point and this point? You just have to remember the formula that is used. So to say the gradient of BC is equal to YB minus YC divided by XB minus XC. So it is wise to name your coordinates so that you don't swap them around. Or some, they can say y1 minus y2, then x1 minus x2. It really doesn't matter as long as you are not going to swap your coordinates around. So let's then substitute. So what is the y coordinate of B? We have 5 then minus y coordinate of C, which is minus 3. So you can just put this minus we are having there, then divided by the x coordinate of B, which is 6, then 1 minus 0 for the formula. So we are having this. So the gradient of BC is going to be the simplified expression of this, which is 8 divided by 6, which is going to be equal to 4 over 3. So this is the gradient of this line. We expected it to be positive, hence the value 4 over 3 is greater than 0. So this is how we can determine the gradient of BC. If the 2 points are given, use the formula, which is change in y divided by change in x. So we are done with this one. Then coming to the second question. Question number 2, we know that the gradient of this line is 4 over 3. So we might use this information later. We really don't have to throw it away. So we are to determine the equation of the line AD. So we really need to remember that the equation of a straight line is given by mx plus c. So m is the gradient of the line, then x is an x coordinate of that line, then therefore c is the constant value. So now we are determining the equation of the straight line AD. So this is the equation of the straight line AD, and if you can expand or to produce this line to this one, this is our value c, which is going to be positive, as you can see there. Now, how do we then determine the equation of this line? So we really need to find or to know the gradient of this line first. It is given, first of all, that this line is parallel to this line. So we can use the same gradient that we have calculated in the question above. So the gradient of this line is also 4 over 3. Why? Because these two lines are parallel to each other. So parallel lines, they share the same gradient. So we of course know that the gradient of the line AD is equal to 4 over 3 then x plus c. So the only thing that you don't know about this line is the value c, which is this value that can be figured out there. So we really don't have to show it that in the diagram. We just need to understand how do we then find the value c after we have calculated or figured out the gradient of this line. Now we really have to use any coordinate in the line that we are looking the equation of. So the point D we don't have, point T is not, there's something that is missing there. We only have the idea of using the coordinate A, coordinate A are to be used to find the C value of this equation. So what are we going to be doing? Are going to be using these coordinates. So in the place of y, we are going to put this y value. Then we have 4/3. Then in the place of x, we put -2, then plus c. So then therefore we can work it out to find what is the value of c there. So the value of c is now going to be 14/3 if you can press your calculator and do all this transposition to the other side of the equation. So the value of c is that, but you are not done. You have to complete to write the equation of this line AD or DA. So the equation is now going to be 4/3, then x plus 14/3. So this is how you can write the equation, but you can also write it this way, which is just 4x plus 14 all divided by 3, because you can see that 3 is the common denominator, so it's common to both terms, so you can just write it under that way. So it's either written this way or that way, it really doesn't matter. So let's then go to the other question. But whatever that we have here, we really need to take it to consideration, because we might need it in some questions that follows. So to this one, we are to determine the value of t. So the value of t here, finally we are now determining the value of t. But where is this t? T is the x coordinate of the point which lies to this line, this straight line. And of course, we do have the equation of this straight line. Let's just take it down because we really need it now. So the equation of the line AD. So whatever that you are looking for that lies in this line, we have to use the equation that we have calculated. So the equation of AD is equal to 4/3, then x, then plus 14/3. So this is the equation that we have, that we are going to use to find this missing x coordinate, which is t in this case. So what are we going to be doing? We have to use this value, these coordinates of n. And what do we have for now? We have the y value, and the y value must be right on the right hand side. Then the x value is of course the value of t. So in the place of x, we are going to put t, because this is exactly what we are looking for. Then the 4 plus 14 divided by 3. So this is what we have. So if we do all those transposition, you will figure out that the value of t will end up being -14/3, because when you take this one to the other side, it turns the signs, and therefore you multiply by the reciprocal of that thing, so which is gonna be now 3/4. So the value of t will then be -14/4, which is gonna be -7/2. So the value of t is that. So you can easily write now the coordinates of n, which is -7/2 is to 0. So we have figured out the value of t. Done. Now moving to the next question, which requires us to determine something else. It is given that if DC is defined as this straight line, determine the coordinates of D. So we are given that DC, which is the equation that we did not figure it out, but now it is given that it is equal to 3/8 x minus 3. So this is the equation of this line. But what we know is that this equation over here is equal to 4/3, then x plus 14/3. This is what we have calculated, remember. So What I like about this equation, somehow, if we move down to the value d, and using this line also you move down to the value d, you will realize that at this point these two equations or these two lines, they intersect each other. So in mathematics we say they are equal, they meet there, so they share the same coordinate there. So what do we mean by that? We mean that the y code, the equation or the equation itself of dc is must be equal to the equation of AD at what? At point D, because D is the point of intersection of both equations of both points. So if we equate the y values of these two equations, then we solve for the unknown values, we are really going to find the equation or the coordinates of D, because we are looking for the coordinates of D, which is x is to y. So how do we do this one? We are going to equate these equations. So we have said this must be equal to that. So what is the coordinates of, what is the equation of DC? Coordinates, the equation of DC is given by 3 over 8, then x minus 3. Let me write it clearly. Minus 3 must be equal to the equation of AD. With the equation of AD is 4 over 3. Then we have x plus 14 over 3. So this is what we have so far. So what are we going to be finding out? We will be looking for what? We'll be looking for the what you call the values of x. We are looking for x now because we no longer have y, we just have x values. So let's try to simplify this one. Let's multiply by 3 throughout. When you multiply by 3, you will then be having 9x over 8, then minus 9. This must be equal to 4x, then plus 14. So which means we have just multiplied each and every term there by 3. We just multiplied by 3 so that we get rid of this 3 and of that 3. So but nonetheless we still have 8 in that way. So let's try to transpose so that we collect the like terms. So at the end of the day we'll be having this over this minus that, so we'll be having 4x. Let's take these values to the other side, so we'll be having 4x minus 9x, that is going to give us a 23 over 8x. Then this must also be equal to, when you take this one to the other side, you will of course get a negative 23. Yes, then therefore what are we having? We have this kind of thing. So on that note, we are going to solve for x. X is going to give us this is gonna be negative 8. If we press, you take this one over there, then you take this one over there, so you are going to really get x being equal to negative 8. Then moving forward, what do you do with this negative 8? You will have to substitute to one of these equations, either to this one or to the other one. You have to substitute by this value negative 8. So what are you having? You have y, which is equal to 3 over 8. Then in the place of x, you of course gonna put negative 8, then minus 3, then the value of y will, when you press your calculator, or you can even solve it manually, you will get negative 6. So these are the values or the coordinates of D when x is equal to negative 8. Your y is going to be equal to negative 6. And of course, your D tells you that both of these coordinates has to be negative, because this is the third quadrant. Third quadrant, all the coordinates has to be positive. Yes, it has to be negative. Hence we are having x being equal to negative 8 and y is negative 6. So which means it gives us the clear idea that really our coordinates be true. Then do we have another question? Oh, let's we have this one. In the diagram, this we are to prove that ABCD is a parallelogram. We have to prove that this is the parallelogram ABCD, this quadrilateral. In order for it to be a parallelogram, what are we expecting? So we really need to now remember the properties of a parallelogram, or the properties of the quadrilaterals at large. So for this one, we can see that DA or AD is parallel to BC. This is what is given. But in a parallelogram, we know that two pairs of opposite sides must be parallel. So we only have one pair now, and we cannot conclude that two pairs are parallel without proving the other pair. So we really have to now use our idea to prove whether these two pairs are actually parallel to each other. And if they are parallel, then this is going to be a parallelogram, because it gives the clear understanding or the full properties of parallelogram. Once two pairs of opposite sides are parallel, then therefore the quadrilateral becomes a parallelogram. So now the idea, because now we already know the equation, the gradient of this one, because the gradient of this one was given in the first place, that it's 3 over 8. It was given in the equation that was given, because you have this one. This was given as equation of the line DC. So this coefficient of x is our gradient. So we just need to figure out whether this line AB as the same gradient as DC. If yes, then therefore this parallelogram or this quadrilateral will be a parallelogram. So now let's just figure out or find the gradient of the line AB. Gradient of AB is given by, I have to use this one, which is y1 is 5, y2 is 2, then we have that. Then x1 is 6, then x2 is minus 2, then therefore we also have to say plus 2, then therefore the answer is 3 over 8. So of course, then therefore the gradient of AB is equal to the gradient of DC. Then A, B, C, D is a parallelogram. Raising both pairs of opposite sides are parallel. So we are done by this one, because we have figured out that both pairs, this line is parallel to that one and this one is parallel to that one, then therefore this is a parallelogram. So we are done with this one. Then moving forward, let's then find or determine the equation. Determine the coordinates of M. Determine the coordinates of M. Remember, we are asked to determine the coordinates of M, which means this point, after we have proven that this is a parallelogram. So of course we know that this is the diagonal of a parallelogram. This is also the shortest diagonal of a parallelogram, and we know what is meant by the diagonals of a parallelogram, that they bisect each other. That gives us the information to say this M is now the midpoint of DB and of AC. So we just now need to calculate the midpoint of AC or the midpoint of BD, because the diagonals of parallelogram, they bisect each other. So we are going to just use that information to find the coordinates of M. So the midpoint of what? Of AC. How do we calculate the midpoint of AC? We say x1 plus x2 divided by 2, then cy1 plus y2 divided by 2. So what is x1? X1, we're going to take this as 0, then yes, 0, then plus x2 is that one, which means it's going to be having negative 2, then divided by 2. Then y1 is going to be this one, which is negative 3. Then y2 is going to be that, then plus 2 over 2. So this one is of course negative 1. Then this one is of course negative half. So these are the coordinates of M. If this is a parallelogram, it is not told that M is a midpoint, but because now we follow the properties of the quadrilateral that is special, and we have proven, then therefore we manage to conclude to say this M is of course the midpoint of these two diagonals. So that concludes this question with full of understanding. But if you really have a problem in one of these, but I feel like I have explained all these touching points, you just have to rewind the video or pause it a bit just to make it a full analysis and consideration of whatever that I've just explained. Otherwise, you can comment on the comment section for anything that you did not get clearly, so that I can come back to you whenever I am free. So let's then go to the second diagram.